So in this lesson, we're going to be adding and subtracting rational expressions. And I'm going to go over some just number examples so we can kind of understand what we're supposed to be doing before I go over some variable examples. So the first one is just numbers. 3/5 plus 2/5. Since they have the same denominators, so right here it says like denominators, you just add the tops and the bottom stays unchanged. So you add the tops, 3 plus 2 is 5. And then the bottom stays the same. And it says always reduce when possible. 5 divided by 5 is just a 1. So let's look on the right side now. And same idea. I have 3 over 5x plus 2 over 5x. Same denominators. So it just becomes 5 over 5x. Your 5's reduced to give you 1 over x. Keep in mind that is not x, that is 1 over x. Now we can think about excluded values as well. If we look on the left, no variables. Therefore that means no excluded values. On the right side are excluded values. We would set 5x cannot equal 0. You divide, therefore x cannot equal 0. Okay, so first example we did was the denominators are the same, so we have like denominators. All we do is just add the tops, bottom stays the same, and we're good. These next examples, we have unlike denominators. So you must find the least common multiple of all the denominators. Multiply the top and bottom, so top and bottom of each fraction to change the least common denominator. You combine like terms on top and reduce, if possible. Take the excluded values from the original fractions. So let's start with the left side with the numbers only. I have 3 over 5 plus 2 over 3. My least common multiple. So least common multiple, I'm going to just kind of work on top just to show you an example. I'm looking at 5, which is my denominator, and 3. Multiples mean when you multiply by something. So 5 by 1 is 5, 5 by 2 is 10, 15, 20, 25. By 3 would be 3, 6, 9, 12, 15, 18. Find the smallest one that they have in common, and that is 15 and 15. Therefore, my least common multiple is 15. So what I'm going to do is find the numbers that multiply to give me that number. For 5, this one here on the left will need to be multiplied by 3 over 3 to give me 15. On the right would be multiplied by 5 over 5. So you can either show your work like this, or you can kind of write it out like this. 3 times 3 over 5 times 3 plus 2 times 5 over 3 times 5. 3 times 3 is 9 over 15, and then 2 times 5 is 10 over 15. Therefore, you get 9 plus 10 over 15, which equals 19 over 15. And that one does not reduce. Let's look at the example on the right now. 3 over 5x plus 2 over 3y. Since there is nothing really in common between this and this, my least common multiple is going to be 5x times 3y. So I will end up multiplying this left side here by 3y over 3y, and the right side here by 5x over 5x. So I end up getting 9y over 15xy plus 10x over 15xy. Since they have the common denominators, I'm going to add the tops. 9y plus 10x over 15xy. And that's my answer. Now excluded values. In my original, I have a 5x and a 3y. So 5x cannot equal 0, 3y cannot equal 0. Therefore, x cannot equal 0 and y cannot equal 0. Next example on the left. So now we're going to subtract. Same idea. However, this time, I have a 5 and a 15. 5 and 15. 5 is 5, 10, 15. Oh look, 15 is just 15, which means my least common multiple is 15. Since the right side already has it, 2 over 15 already has a 15 on the denominator, I only need to multiply my left side. Multiply this by 3 over 3. That gives me 9 over 15 minus 2 over 15. You combine the tops, 9 minus 2 over 15 is 7 over 15. Don't forget, no variables means no excluded values. I do want you to start writing that, so let's make sure we add these into all of them. Now let's look at the one on the right. So now for the example on the right, 3 over 5x minus 2 over 15xy. We can actually say this 15xy is like a 5x and a 3y. Since we have these in common, my left side only needs a 3y and a 3y. So notice how I factored it out to kind of find my least common denominator. We're going to do that even more for the next two examples. So to multiply it, I get 9y over 15xy minus 2 over 15xy. And I get an answer of 9y minus 2 over 15xy. Excluded values. 5x cannot equal 0. Therefore, x cannot equal 0. 15xy cannot equal 0. Therefore, x cannot equal 0 and y cannot equal 0. Go on to these next three examples. It says on the right, if the denominators have more than one term, factor the bottom only to find a good least common denominator. Multiply top and bottom of each fraction to change the new least common denominator. Combine like terms on top. Factor the top if possible to see if the fraction can reduce. State the excluded values. The denominators of the original fractions cannot equal 0. So if we factor the bottoms, this one here on the right can be 3x, then x plus 1. On the left is actually 3x and 3x. So my least common denominator will be, since this one has 3x, here's what we're going to kind of do to kind of make this a little easier. Find what they have in common. So they have a 3x and a 3x in common. I'm going to put 3x here. Since they have nothing else in common, I'm going to just write the rest of it out. 3x and x plus 1. Therefore, my least common denominator, I can kind of multiply the two 3x's if I wanted to give me 9x squared x plus 1. So this is what I'm looking for. So once again, I found what they had in common, and I crossed it out and wrote it down here. Since there was nothing left in common, I just wrote them down and multiplied it. You can multiply it all, you can multiply one piece, up to you to kind of see what's going to help you understand what needs to be multiplied at each. So once again, since I know that this is 9x squared and this is 3x x plus 1, my left side is missing the x plus 1. The right side is missing another 3x because it only has 1 and it required 2. So when I multiply, I end up getting 7x plus 7 over 9x squared x plus 1 plus 3x squared over 9x squared plus x plus 1 combine like terms. Sorry, not combine like terms. You're going to add the tops to give you 3x squared plus 7x plus 7, it's in standard form, over 9x squared x plus 1. Nothing else can simplify. The top is not factorable, so that's it. Excluded values, we're going to look at nine x squared, therefore x cannot equal 0. We will also look at the 3x and x plus 1 cannot equal 0. Therefore 3x cannot equal 0, so x can equal 0, and x plus 1 cannot equal 0, therefore x cannot equal negative 1. Let's go and look at one more example. X over 3x minus 15 minus 2x plus 2 divided by x squared minus 4x minus 5. Factor first. 3 and x minus 5. The other side, if you did the super x, you would get x minus 5, x plus 1. So, in common first, x minus 5, x minus 5, x minus 5 here. Nothing else is in common, so I'm going to write the rest, which is a 3 and an x plus 1. This is my least common denominator. So now I look to see what is missing in each. The left side is missing an x plus 1. The right side is missing just a 3. So on the left I get x squared plus x over 3x minus 5 x plus 1 minus, on the right side I get 6x plus 6 over 3x minus 5 x plus 1. You subtract them. That would give me x squared minus 5x plus 6 all over 3x minus 5x plus 1. Now, you want to factor the top to see if there's any part of the fraction that can reduce. The top would give you x, if you do the super x, top would give you x minus 6, x plus 1 over 3, x minus 5, x plus 1. X plus 1s can reduce, therefore your final answer is x minus 6 over 3x minus 5. Let's look at excluded values. So my excluded values, I will be looking at 3, x minus 5 cannot equal 0, therefore x minus 5 cannot equal 0, therefore x cannot equal 5. And x minus 5x plus 1 cannot equal 0. This is x cannot equal 5, and x cannot equal negative 1. I'll do that last example in class.